Hello everyone, welcome to the third tutorial in the simulation series, and this is the second tutorial using the library salabim. So for this tutorial I'll be showing you a more practical example. The previous example of salabim was just a simple simulation of a car which starts and stops. So this is going to be a tutorial of a queue with the example of the customers entering a bank, getting served by the clerk and going back. Classic queuing example. So this is a very simple example of queuing where the customers are arriving. Let's take, say, every 1 minute, customers arriving, they join the queue, and they're getting served by the clerk, and they leave. And they keep on coming. Sometimes the queue length could be greater than 1. So now let's see how to model it using salabim. So step 1 is import salabim as sim. The comments, let me write bank example. Comments, let me show the link where the example is. So step 1 was importing the simulation library salabim as sim. Let's define the different classes. So in this case we'll have 3 different classes. Let me go back to the slide real quick. So the first one will be a CustomerGenerator class. Second one would be the customer itself. So let's write it here. Create 3 classes. CustomerGenerator, customer, and the clerk. Let's go back. So first example is CustomerGenerator. sim.Component. You're defining the process using which the customers are being generated. So def process self. This is where we're starting the while loop to ensure that this customer generation process continues till we stop the simulation. So while true, simple while loop, you're creating a customer, and the second class will be the customer class. So we're going to get to it in a little bit. Yield self.hold sim.Uniform. So essentially what this means is, like, from a uniform distribution with the lower bound as 5, upper bound as 15, a time unit is chosen, and customers are arriving every time unit. So after this, dot sample to do the statistical sampling. Make sure. Oops. Second one is the customer class. Again, we use sim.Component. Let's define the process. Def process self. Self dot enter. So this is the property of a sim.Py class, which is called the queue. I'll get to that in a little bit. Waiting line. So waiting line is going to be an object, or an instance of the sim.Py queue class. If clerk.ispassive clerk.activate yield self.passivate, and finally the clerk class. So here we are defining the process of the clerk. While true, while length of this queue is 0. Passivate. Self dot customer equal to waiting line dot pop. So this uses the standard Python list property dot pop, which essentially means removing the customer. Then yield self.hold 30, self.customer.activate. Alright. So we did a lot of things. We essentially created the 3 classes here. First was a customer generator class, second one was the actual customer class, and third one was clerk. So let's define the objects now. So first, if you remember, the first thing we have to do is define the simulation environment. So env equal to sim dot, so sim is essentially the alias for the salabim library. Sim dot environment we'll put trace equal to true. This helps us, again, so just trace the simulation. So we're essentially instantiating the classes. So CustomerGenerator is going to start the process of generating the customers. So every time it generates this, so let's take, say, 5 time units, taking the lower bound, so every 5 time units is going to generate a customer. Secondly, we are defining a clerk object. Here we are assuming this one clerk. And then we are defining or instantiating the queue class. So we are defining an object waiting line, essentially sim.queue, giving it the name waiting line. So let's say we want to run it env.run equal to 50 time units, print waiting line, because we want to print statistics of the queue. There's our code. Save it. Let's make sure this runs. Okay, this runs. So as you can see, it's creating the customers. Cool. So it has ran for 50 time units, and you can see the statistics of the queue says that length of waiting line. So median says that 1.3 people or 1.3 customers were in the queue. 95 percentile 2.8. Maximum was 3. So at a time there were 3 customers in the line. Length of stay, so the mean is 7.6 time units, minimum 0, maximum 15. So now let's try and understand what we really did here. And again, like this particular example is also in the documentation, and this is a link for the documentation. So the first part here in the CustomerGenerator class, what this is doing is it's doing the statistical sampling, and then essentially it's waiting for a certain amount of time till creating or generating the next customer. So it takes a random number out of this uniform distribution with lower bound 5 and upper bound 15, and it waits for that certain time interval before generating the next customer. So let's look at the next class, or the customer class, and let's look at this process. So like this one says, so we defined the object waiting line as an instance of the inbuilt salabim queue waiting line. So whenever the customer is created, so this calling essentially the customer, it enters the queue. And what does it do here? Sees if the clerk is free or if the clerk is idle, and activates it. So if clerk is passive, it activates it. And after that, so if clerk gets activated, here you have the clerk class, all these processes are taking place. So what this does is, when the clerk is active, so let's look at the flow. It activates the clerk, we go here. So when the clerk is active, it gets the first customer out of the waiting line and holds it for 30 time units as processing time. And when it activates the customer, essentially is idle. So these are the three main classes that we defined. Hope this was useful. We'll have another tutorial shortly. Thank you.